8.1 Vector and parametric equations of line in R2. Example 10. Consider the line through two given points as shown in the figure below. Write the vector equation of the line. Draw a triangle that represents the vector equation using points A and B. So here's a line given to us, and these are the points A and B. Coordinates of point A are 4 and 1. So we have a point A whose coordinates are 4 and 1. Coordinates of point B are 2 and 2. Right. So the direction vector M we can actually find from the diagram and from here also. So let's do it from the diagram itself. So we can go either way. You can go from B to A or from A to B. It's one and the same thing. So if you go from B to A, we go 2 right, 1, 2, and 1 down. Therefore, this is 2 right and then 1 down, right? So we can write direction vector M equals to x coordinate is 2 and y is -1, correct? So that's the direction vector. Now if you know the direction vector and one point, then you can always find the vector equation, right? So vector equation, we say R, we'll use this formula, right? R is equal to any one of these points, let's say 4, 1, plus scalar multiple of this direction vector. So that's our vector equation. Now you could have found direction vector from here also. You can say 4 minus 2 will give you 2. 1 minus 2 will give you -1. So that's also a way to find direction vector, second from the diagram as we did. Now to draw a triangle that represents the vector equation using points A and B is like this. So this is, now we'll refer to our general equation, R equals to R0 plus T times M, where R0 is the initial coordinates of the point on the line. So let's consider A to be those initial coordinates, right? So we say from here, from origin, we'll connect A, and this is our vector R0. That's our vector R0, correct? So that is R0. T is a scalar multiple of direction vector. So that's the direction vector from A to B. This is scalar multiple of our direction vector. So we will call this T times M. And then this R0 plus T times M is equal to our vector R that represents the vector equation of our line. Do you see that? Using the points A and B. And this is the triangle we're talking about. Draw a triangle that represents the vector equation using points A and B, right? So we draw a triangle here. R0 is our point A, which is 4, 1, plus that represents Tm, right? And then we get our vector equation. So R vector is equals to R0 plus T times M. That is vector R equals to this plus this. So that's That is how you can understand how we have derived this vector equation, right? And from here, you know how we derived parametric equation. We have split this equation into two parts for the two variables, x and y, right? Since r0 could be written as x0 and y0, right? And t times m could be written as is direction numbers a and b, right? A is along x-axis, horizontal, and b is vertical y-axis, right? So when you split them, then you get your x and y, any particular coordinate on the line, right? Any point on a line. So from here, x is equals to x0 plus t times a, right? You can write this as at, right? And y equals to y0 plus b times t. So that gives us the line AB. Okay, we can write AB for the moment, right? Well, this is not the part of the question asked, but that could be part C. Okay. So just for your understanding, here we have graphically represented both the equations and shown you how vector equation and the parametric equation are related. I hope you understand. Thank you.